Hey, Mr. Mutford here. I'm going to show you a process for finding the derivative of any inverse trig function. What we're going to do, it's a video, I'm going to go fast, replay it several times. You have that privilege. So, let's say arc sine or inverse sine of x this time. What we need to do first is we need to make that into an equation. Y equals that thing we want to take a derivative of, and then we take the derivative of it. Now, leave this here. We'll come back to this later. Go the other way. Let's move the trig function over so it's not an inverse trig function anymore, and that just frees up the x here, and now take the derivative of both sides. Good news on this side is you get this dx ratio 1 to 1. That's a very nice number. But let's go over here. We can take the derivative of a sine. It's just a cosine. However, with respect to x, that's going to pop out a chain rule. Make sure the chain rule is there because we want to make a connection right here. This is what we're solving for. This is an equation we can use to solve for it. So we move the cosine over by dividing it through. Here's where you're going to have a little bit of a mental block, but that's okay, because what we're going to do next is we're just going to set up but make a picture. To make a picture, let's convert this to the ratio x divided by 1 so that we can exploit the ratio definitions of this sine where we have an opposite and a hypotenuse. So we draw the triangle. We put angle y into the picture so that we know our opposite and our hypotenuse. One step of Pythagoras away, and you are done and can fill in what cosine of y is because here's your tool for that. Simplify and you're done. Let's see that process in 2 twists, just so you know it's nothing special about inverse sine. First of all, what if you had a hyperbolic inverse sine? Same exact everything in the process with one catch over here. Please make sure with hyperbolic functions, when you draw this picture, your vertical, your opposite side, is imaginary. So whatever it is, times I. Then follow that through, and you wind up with the answer. Same exact process otherwise, but it just makes the Pythagoras a little bit different. Then, over here, what if you had a function of x instead of just x? No biggie. When you get to this step here, you're just going to put the f of x into the Pythagoras over here. If it happens to have the hyperbolic imaginary or not, does not matter. They're interchangeable tools that can come in and work together. I shouldn't say interchangeable. There's tools that work together for combined situations. And then over here, it doesn't equal 1. It just equals f prime, or the derivative of f with respect to x, and whatever it is, it is. You do have to be a little bit careful here. There are some domain restrictions, so you might get some absolute values thrown in. But this just gave you all 12 formulas, including when it's not a pretty little x, but a function here. You can take a derivative of any of these now. Hope it's been helpful. Thanks. Bye.